everyone. For today's lesson, we are going to learn about what it means to find the measures of central tendency and dispersion, as well as apply data transformations, which is very fancy language for identifying the mean, median, mode, range, and standard deviation of a set of data, as well as identifying what happens whenever you add or subtract the same number to a set of data. We're going to analyze what happens to mean, median, mode, range, and standard deviation. But before we get started, I would like you to go ahead and perform the indicated operation and simplify. I want you to simply subtract these fractions. Remember that in order to subtract fractions, you need a common denominator. So we have x over x minus 3, x over x plus 3 minus 3 over x plus 2 minus 1 over x squared plus 5x plus 6. Please pause the video and add these subtract these fractions together. And when you have an answer, go ahead and restart the video and we'll see how well you did. All right, in order for you to subtract fractions, like I said, you need a common denominator. So what I'm going to do is I'm going to identify what that common denominator could be by factoring the x squared plus 5x plus 6. And when I factor that, I end up with an x plus 3 and an x plus 2. So that indicates that my least common denominator needs to have an x plus 3 and an x plus 2. Well, my first fraction has an x plus 3, but it doesn't have an x plus 2. So I'm going to multiply both the numerator and the denominator by x plus 2. My second fraction needs an x plus 3. So I'm going to multiply both the numerator and the denominator by x plus 3. Since my last fraction already has the common denominator, I don't have to adjust it in any way. What I do know is that my common denominator is going to be x plus 3 times x plus 2. So I'm going to FOIL in the numerator and keep my denominator in factored form. X times x is x squared, and x times 2 is plus 2x. Minus, you have to be careful here. This minus 3 is going to be distributed to each term. So that's going to be minus 3x minus 9. So minus 3x times 3 times 3 is 9. So minus 9. And then I have this minus 1. So now I'm going to combine all of my like terms in the numerator and end up with x squared minus x minus 10 all over x plus 3 times x plus 2. And that is your answer. You cannot factor the numerator. There doesn't exist two numbers that would multiply together and to equal -1, yet together when they multiply together they equal -10, but together at equal -1. It just doesn't exist. So therefore, this is our answer. Now, I don't want you guys to forget how to add, subtract, multiply, and divide fractions because they will reappear in June. So from time to time, I'm going to be inserting warm-ups like these where you have to kind of go back and refresh your brain on topics that we haven't seen in a while. For today's lesson, I want you to be able to say, I can calculate the measures of central tendency, which you're going to find out in our mean, median, and mode, and then I want you to also identify the measures of dispersion, which are range and standard deviation, by hand and using a graphing calculator given a set of data values. So for today's lesson, you will need a scientific calculator and a graphing calculator. If you do not have a graphing calculator at home, that's okay. It won't prevent you from not being able to finish these notes. It just means that you and I might have to have a one-on-one conversation when I see you next time. So, the next I can statement is I can describe the effect an outlier adding a constant to all data value and or multiplying a constant to all data value has on the measures of central tendency and dispersion. So we're gonna discuss that. But before we get started, let's go ahead and define a few terms in statistics. So this unit is called the statistics unit in analyzing data or data analysis. So statistics just represents things that describe data. So numerical values can be used. To summarize and compare data sets. Two important types of statistics are measures of central tendency, which is a number that can be used to represent the center or middle set of data values, and it can be represented by the mean, the median, and the mode. There also exist these things called measures of dispersion, and that is a statistic that tells you how dispersed or spread out the data values are. And this can be represented by the range, and a new word that you probably have heard about but maybe have never really, you don't really know what it is, and that's called standard deviation. D-E-V-I-A-T-I-O-N, deviation. Make sure that's right, deviation. And we're going to talk about how to calculate those in just a moment. There exists another word that you might see a lot, and that is outlier. And an outlier is simply a value that is much larger or much smaller than most of the other data values in the set. So it kind of like pulls your data lower. So if you can imagine being a student who is an A student, you get 90s, your test scores are always in the 90s, and then all of a sudden you get a D or fail a test. That's considered an outlier. It's not your typical score that you normally get, and it'll bring your overall grade completely down. Or on the other hand, you're a student who struggles and you get C's and D's on your tests, and then all of a sudden you get 100%. That 100% is considered an outlier, and it's going to pull your average up. So we're going to talk a little bit about outliers a little bit later. So the next thing I want to do is talk about measures of central tendency in greater detail. The first one is mean. Mean represents the average of your n numbers. So n is going to be something that you're going to see often, and n represents the total number of data values. So you might see the letter n, and it means the total number of data values. The sum, the way to calculate mean, is the sum of the numbers divided by n. So you add all of your numbers up and divide by the total number of numbers that you added together. It is denoted in statistics as X bar. So you're going to see into your calculator X bar. So I'm going to be expecting to see that when you're telling me what the mean is, that you're going to use the notation of X bar. The next word is median. Median of n set of numbers is essentially the middle number when the numbers are written in order from smallest to largest. So I need you, sometimes your data values are not going to be written in smallest to largest or largest to smallest. You will need to make sure that you reorder your numbers in a way that makes sense. Also, if n is odd, then the median is the middle number. So for example, if you have 2, 4, 6, 8, and 10 as your data values, your median is the middle number. There's a total of 5 values, and we're just going to cross off 1 on each end, and then another on each end, and 6 is the middle number. So our median in this case would be the number 6. However, if n is even, then the median is the average of the two middle numbers. So let's say that we have 2, 4, 6, and 8. That means that our two middle numbers are 4 and 6. And in order to find your median, it does not have to be one of your data values. It's simply the average of your two middle numbers. So that's going to be 4 plus 6 cut in half. So that's 10 divided by 2, which is 5. Your median is going to be the number 5. Next we have mode. And mode represents the number of numbers. So sometimes it can be more than one. So it's the number or numbers that occurs most often. So mode sounds like most. And so whenever you're looking for the number that occurs most often, that's called your mode. Now, a data set can have no mode, one mode, two modes, etc. It just depends on what we have in our data. All right, then we have ourselves the measures of dispersion. So think about things dispersing into the air. It's kind of going to be spreading out into the air. So that's the kind of one of the ways to think about it. Think about it as spread out. How spread out is our data values. So it describes the spread. So your range is the difference between the greatest and the least data values. So sometimes it's important to list your values or list your data in order to identify your least and your greatest. So your range is going to be your greatest number minus your least number. And when you subtract, you're going to end up with one specific number. So a lot of times we've used in just regular language that the range is from this to this, not in statistics. In statistics, your range is one specific number, and you find it by subtracting the greatest minus the least. Next, we have standard deviation, and this is a new word. Standard deviation represents the typical difference between a data value and the mean. So what we want to do is we want to figure out what is the typical distance that any sort of value is away from the mean. And there exists an actual formula that you will need to know by hand, so please make sure that you know and study how to calculate standard deviation by hand. The symbol that we use for it is lowercase sigma. And it is the sigma of x1, x2, x3, xn. And these values right here are your data values. So the formula is sigma is equal to, or the standard deviation of your data is equal to the square root of x1, which is your first data value, minus x bar, which is your mean, squared, plus your next data value, we'll call it x2, minus your mean, squared, plus your next data value, all the way up until your final data value, which we call x sub n, minus x bar, which is your mean, squared. And then we divide all of that, still under the square root, by n. And once again, n represents your total number of data values. This is a formula, like I said, you need to know and study. You need to know how to apply it. And there, I'm going to show you some ways for you to calculate this rather easily so it's not so tedious. Let's go on to the next page. So in example number 1, it says the data set below gives the quiz scores for a biology class. We want to find the mean, median, mode, range, and standard deviation of the set by hand. So this is something that you will have to do on your test. So please make sure that you study example number 1 because there will be a question like that on your test. So the first thing you want to do is you want to make sure that your data is in order. So I think that it is, but I have 15, 17, 17, 17, 18, 19, 21, 22, and 25. Cool, my data is in order. Awesome. The first thing I want to do is I want to identify my mean. Now remember that mean, we use x bar. So that's where you add up all of your values. It's 15 plus 17 plus 17 plus 17 plus 18 plus 19 plus 21 plus 22 plus 25. And this is all over. Let's add up all of the values. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. And I believe that I listed 9 numbers. So we're going to divide by 9. What I would recommend is just putting the numerator into your calculator. Don't put the whole thing into your calculator. Just put the numerator into your calculator. So just the numerator and come up with a value. So when you put 15 plus 17 plus 17 plus 17 plus 18 plus 19 plus 21 plus 22 plus 25 into your calculator, you end up with 171 over 9. And 171 divided by 9 is 19. So the reason why I recommend that you put just your numerator into the calculator is because it's a lot easier to put a little fraction into your calculator to calculate your mean than it is to put this whole thing in there. There's somewhere where you can make some errors and your calculator won't produce the answer that you want. So your X bar is 19. The second thing we want to do is we want to identify our median. So our median happens whenever we identify our middle number. And since there are 9 data values, we simply need to identify the middle number. So I'm going to cross off 2 on each side. Unfortunately, I don't think I'll have to average because it's an odd number of data values. Then I'm going to cross off the next 2 middles, or I'm sorry, the next on the sides. And I'm going to keep crossing off until I identify my middle. And it appears that my middle, or my median value, is 18. Next, I'm going to identify my mode. The mode is the number that occurs most often, and the number that occurs most often in this case is 17. So there's not a lot of thinking that goes along with that, just that the mode occurs most often. Next is range. So your range is your greatest number minus your smallest number. So it's your greatest number minus your smallest number. So my greatest number is 25, and my smallest number is 15. And 25 minus 15 is 10. So far I have my mean, median, mode, and range. And now I've left all of this space to calculate my standard deviation. So I'm going to write number 5, and this is standard deviation. And remember that standard deviation has its own symbol, and that symbol is called lowercase sigma. And the way that I would draw it is that it's like a teardrop and then like a tail that comes off of it. And so that's how you draw a standard deviation, the symbol for it being sigma. So I'm going to write out my full square root, and I'm going to take my first data value, which is 15, and I'm going to subtract it from the mean. The mean in this case was 19. So I'm going to take 15 minus 19 and square it. Then I'm going to write a plus sign, and my next value is 17. 17 minus 19 squared. Plus, my next value is 17. 17 minus 19 squared. Plus, my next value is 17. 17 minus 19 squared. Plus, my next value is 18. 18 minus 19 squared. Plus, my next value is 19. 19 minus 19 squared. Plus, my next value is 21. 21 minus 19 squared. Plus, my next value is 22. 22 minus 19 squared. Plus, we have 25 minus 19 squared. This is all over. We had a total of 9 values. So how can you make this process a little bit easier? Well, what I would recommend that you do is just like we did with mean, where I said let's put our whole numerator into the calculator, you can put this whole numerator into your calculator without the square root. But that might even still be pretty complicated. So what might be even easier is to work with each parenthesis individually and just come up with a number. So I'm just going to write out another square root, and I'm going to identify what each parenthesis becomes. 15 minus 19 is negative 4. Negative 4 squared is 16. Plus, 17 minus 19 is negative 2. Negative 2 squared is 4. So the next one's going to be plus 4, and then the next one's going to be plus 4, because 17 minus 19 squared occurs 2 more times. Plus, 18 minus 19 is negative 1, and negative 1 squared is 1. Plus, 19 minus 19 is 0. And 0 squared is 0. You don't have to write it, but sometimes it's helpful just to keep track of everything. 21 minus 19 is negative 2, and negative 2 squared is 4. Plus, we have 22 minus 19, which is negative 3, and negative 3 squared is 9. Plus 25 minus 19, that is 6, and 6 squared is 36. And I'm going to divide all of that by 9. So now we just have a total of 9 numbers that we're going to be adding together. And I'm just going to add those together and put them into my calculator. And when I do that, I end up with 78. So now I'm going to take the square root of 78 over 9. And that's a lot easier to put into our calculator. And what I mean by calculator is that this is the scientific calculator. So in your scientific calculator, you're going to do the square root of 78 divided by 9. And you're going to close your parentheses, and you end up with the answer of 2.944. 2.944. Whenever you are coming up with your standard deviation, the preferred method, especially if you're going on to any sort of statistics class, whether in high school or in college, is we prefer you to round to the nearest thousandth. And that is your answer. So a lot of that can take a long time. So thank goodness we have our graphing calculator, especially if we have as many data values as we have down here. We have a total of 43 data values. So this says, the data set below gives the ages of the first 43 presidents of the United States when they first took office. So here are all of our ages, and what we're going to do is we're going to enter in all of these values into your calculator. So in order for you to enter them into your calculator, the first thing that you want to do is you want to clear your list. So in order for you to clear your list, you're going to press second and then the plus sign, and then you're going to go down to number 4, which is clear all lists. And then you're going to press enter. And you might have to press enter again because you need to see the word done. So I'm going to press second plus sign. I'm going to go down to number 4 where it says clear all lists. And I'm going to press enter so that I can see the word done. Next, in order for us to enter data into our calculator, we're going to press the stat button and then we're going to press edit. So stat and then edit. So I'm going to press stat, which is located below delete, and then edit, and I'm going to list in just list 1. I'm not listing ordered pairs. This is just a list of data values. I'm just going to list all of these all of the presidents' ages. So just give me a moment to enter in all of these values. And then I'm going to go ahead and show you how you can find all of the statistics up here rather quickly. So here we go. I have 57, 61, 57, 57, 58, 57, 61, 54, 68, 51, 49, 64, 50, 48, 52, 56, 46, 54, 49, 51, 47, 55, 55, 54, 42, 51, 56, 55, 51, 54, 51, 60, 62, 43, 55, 56, 61, 52, 69, 64, 46, and 54. And hopefully I didn't miss any. It looks like I might have missed some. So hopefully, let's go back to the beginning. All right. 57, 61, I had two 57s, awesome. So I'm going to press 57 to replace it, and then I'm going to press second insert, and I'm going to put in a 57. Okay, cool. So 57, 57, 58, 57, 61, 54, 68, 51, 49, 64, 50, 48, 65. So I need to enter in 65. All right. Then we have 52, 56, 46, 54, 49, 51, 47, 55, 55, 54, 42, 51, 56, 55, 51, 54, 51, 60, 62, 43, 55, 56, 61, 52, 69, 64, 46, 54. There is a total of 43 presidents. Notice I have a 43 right here. So in the event that you do mess up, please make sure that you go through the entire process. So on your test, if you make mistakes just like I did and you cannot identify your error and you didn't realize that you made an error, then go through the whole process and you'll lose just like a half a point or a full point for not entering your data incorrectly. But if everything else is correctly, you'll receive full points for your mistake. So I'm just putting that out there. And for the rest of the lesson, I already have the data already entered in. So now what I'm going to do is, in order for me to identify the mean, the median, the mode, the range, the standard deviation, I'm going to press stat. And from there, I'm going to press the right arrow to calculate. So now I'm going to press stat again, and then I'm going to press the right arrow, and I'm going to identify calculate. And I want one variable stats, one var stats. So one variable stats means that we're not working with x's and y's, we're just working with a set of data values. Some of you, when you click one variable stats, might end up with like a little list that comes up. Some of you might have a blank screen. Some of you might have a screen that looks like mine. You can just press enter again, and then when you do that, you'll end up with all of your stats. Notice our X bar is given to us, and our X bar, which is our mean, is 54.837. Our median, if you scroll down, your median is MED. Our median, that is 55. We didn't even have to reorder these in order. They'd already told us what our median is. Our mode, we'll have to identify our mode by hand. And we'll do that in just a second. Our range, well, what's cool is that they tell us what our minimum value is and our maximum value. Our maximum value is 69. Our minimum value is 42, and 69 minus 42, that is equal to 27, so our range is 27. Standard deviation is given to us. Standard deviation, if you scroll up, it's going to be the standard deviation of x, so you'll see that symbol, and that symbol is going to give you, tells us that our standard deviation is 6.145. So the only thing that the calculator does not tell you is the mode. So you have to analyze the numbers. And when you analyze the numbers, we can look at the number 57. And 57 occurs 4 times. And the next number that kind of looks like it repeats most often is 61. And 61 occurs 3 times. But it's the number 54 occurs 5 times. And the number 51 also occurs 5 times. So our mode in this case, we have 2 of them. It is the ages of 54 and 51. And so that's how you would identify your information from a calculator. You would enter in all of your data points, and then you'd go to one variable stats, and then from there you can identify your mean, median, range, and standard deviation, and then you'll have to calculate your mode by hand. Let's go ahead and look at example number 2. For example number 2, it says the data set gives the median or the midterm scores for a chemistry class. And the scores are given right here. Using a graphing calculator, identify the mean, median, mode, range, and standard deviation. So, fortunately for us, I already have the data values already entered into my calculator. So I've already went to second plus sign, cleared my list, press enter, I went to stat, and I entered in my values. So here are all of our test scores for this midterm test in chemistry. Now from here, I'm going to press stat. I'm going to go over to calculate, and I want one variable stats. And you might have to press enter. Sometimes it'll automatically come up. But in this case, our mean is going to be 90. Our median, I have to scroll down, is 90. Our mode, we'll have to calculate in just a second. Our range is going to be 98 minus 83. And that is equal to 15. And our, this goes down here. 98 minus 83 is equal to 15. Our standard deviation That's going to be 4.796. And then let's go ahead and identify our mode. So all you have to do is look at your data values and identify something that repeats. 84, 89, 98, 86, 96, 83, 87, 93, 93. So 93 occurs twice, and our mode in this case is going to be 93. All right, cool. So it says, after the students took the midterm test, the teacher gave a bonus assignment. So the teacher adds 5 points to each score. Using the graphing calculator, find the mean, median, mode, range, and standard deviation with the bonus of 5 points. So if the teacher is adding 5 points to the score, instead of going back and re-entering in all of your data by adding 5 points, here's a shortcut. I'm going to go to Stat, and I'm going to go back to Edit, and so here is my original list. I'm going to press the right arrow. And when I press the right arrow, I'm now in list 2. I'm going to press the up arrow so that list 2 is highlighted. So I pressed over so that I was in list 2, and then I highlighted list 2. Once list 2 is highlighted, press enter. What you now have is a blinking box next door to the equal sign. And what we want to do is we want to take list 1 and we want to add 5 to all of the values. So list 1 is located down here in blue for my calculator above number 1. So I'm going to press second 1, and when I do that, L1 appears. So I press second 1 and L1 appears, and I want to add 5 to all of my list 1. So I'm going to write plus 5. Then I'm going to press enter, and now all of my values have just had the number 5 added to it. So now I'm going to identify the mean, median, mode, range, standard deviation of my list 2. So once again, I'm going to press Stat, I'm going to go over to Calculate, and I'm going to go to one variable stats, but this time I don't want it to be of list 1. I need it to be of list 2. So I'm going to press second L2 so that it's of list 2, and then I'm going to press enter. And what I did is, so by putting in L2, so L2 was located at second, the number 2, that's where L2 is located. And by doing that, I now have all of my data values for list 2. My mean is now 95. My median is now 95. My range is going to go from 103 minus 88, and 103 minus 88, oh, I did it again. 103 minus 88 is equal to 15. If I added 5 to all of my values, that would make this 98, and this would be 98. So this time around, 98 is going to be my mode. And my standard deviation, if I scroll up, is 4.796. So 4.796. So what happened in this case? Well, 90 became 95, 90 became 95, 93 became 98, 15 stayed 15, and 4.79 stayed 4.79. So our mean, our median, and our mode increased by 5, and then our range and standard deviation remained the same. So when a constant is added to every value in a data set, the following is true. The mean, median, and mode of the new set can be obtained by adding the same constant to the mean, median, and mode of the original data set. The range and standard deviation are unchanged. This statement is incredibly important. This is how you're going to analyze your data. I'm going to ask you what changes, what doesn't change, how does it change, things of that nature. And we can certainly talk about why this occurs next time I see you. Let's go ahead and look at example number 2. In example number 2, it says the data set lists the winning distances in meters in the women's Olympic javelin throw from 1968 to 2004. Using the graphing calculator, find the mean, median, mode, range, and standard deviation of the distances in meters and in yards. So once again, I went second and plus sign, I cleared all my lists, and then I entered in all of my information. And what's given to us is our information in meters. And then we'll change it into yards later. So I've already entered this data into my calculator. And notice in list 1, I already have my information. So I'm going to press stat, and I'm going to go over to calculate, and I want one variable stats. And I want list 1. So instead of list 2, I need list 1 because that's where my data values are. So I'm going to press second and then the number 1 because that's where list 1 is located. So I want to identify my information about list 1. And then I'm going to press enter, and here I go. My mean is going to be 20.87. My median, if I scroll down, is 20.9795. I'm going to remind myself not to put anything here. My range is 22.41, so I'm going to write 22.41 is my max, minus my minimum, which is 19.59. And that is equal to 2.82. And then my standard deviation is 0.892, so 0.892. And my mode, well, I have to look at my situation and which numbers occurred most often, and it appears that I only have one set of repeats, and that is 20.56. So now what we want to do is we want to convert our meters into yards, and I have a conversion note for you. 1 meter is equal to 1.094 yards. So what that means is that I need to multiply all values by 1.094 because I'm converting it into yards. So once again, I'm going to go to my table, and I'm going to go make sure that I'm in list 2, and I'm going to press the up arrow so that list 2 is highlighted, and then I'm going to press enter. I now have a blinking box down here, and what I want to do is I want to make list 1, which is going to be second and the number 1. I want to take all the values in list 1 and multiply them by 1.094. So I want to multiply all my values by 1.094, and I'm going to press enter. I now have a new set of data values, and I want to identify the mean, median, mode, range, and standard deviation. So I'm going to press stat once again, and I'm going to go over to calculate, and I do want one variable stats again, but I want this time to just look at the information in list 2. So I'm going to press second 2. And when I do that, I'm going to press enter a few times, and I end up with my mean is going to be 22.832. My median, in this case, is 22.75, rounding it to the nearest thousandth. The next one, I'm going to leave a little bit of space for mode, and I'm going to come down to range, so that's going to be 24.517 minus, I have 21.431, and that's going to be equal to 3.085. Then I have standard deviation, which is going to be 0.076. I'm sorry, 0.976. And then my mode. Well, I'm just multiplying all of my values together, so all I'm going to do is I'm going to multiply 20.56 times 1.094. And I end up with 22.493. Okay, so in order for us to get the mode, I said that you needed to multiply it by 1.094. Well, let's go ahead and check. Can I go 20.87 and multiply that by 1.094 and get pretty close to my new mean? And the answer is yes. So what I'm doing each time is I'm multiplying the mean, median, and mode by 1.094. But look, the range and the standard deviation also changed. So you can check. Is 2.82 times 1.094 equal to 3.085? It is. So also, the range and the standard deviation are also multiplied by 1.094. Everything was multiplied by 1.094. So the bottom line is that when each data value is multiplied by a constant, the new mean, median, mode, range, and standard deviation can be found simply by multiplying each original statistic by the same constant. So you do not have to work with list 2 in order for you to come up with those values. You simply need to know the trick that in order for you to come up with those new statistics, you just need to multiply everything by that constant. We have one more example and then we are finished for today. It says, examine the effect of an outlier when using your graphing calculator. We have the winning scores for the first 9 games of a soccer season are given. So I already have those values in my calculator. And what we want to do is we want to find the mean, median, mode, range, and standard deviation. So I'm going to go to my data values. They're already in my calculator. And then I want to check out my one variable stats. So I'm going to press stat, edit. I want list 1 variable stats, and here we go. My mean, which is x bar, is 3. My median, scrolling down, is 3. My mode, I have to find later. My range, that's going to be my maximum, which is 5, minus my minimum, which is 1, which is 4. So my range is 4. And then my standard deviation, which is the symbol of lowercase sigma, that is 1.155. And now I need to find my mode. So looking at all of my numbers, it appears that the number 3 occurs most often, so my mode is equal to the number 3. Now it says the winning score in the next game is an outlier, so it's the number 9. Find the new mean, median, mode, range, and standard deviation. So I'm going to go back to my list, and I'm going to go to the very bottom of my list. And at the bottom of my list, I'm going to enter in the number 9. All right, awesome. So that's considered an outlier. So now I'm going to calculate the new one variable stats. Going through my steps again, my mean is now 3.6. My median is 3 still. My mode is still going to be 3 because all I did was add an extra 9 on the outside. So that's going to be 3 because it still occurs most often. My range, this time my largest is going to be 9. My smallest is still going to be 1. And that's going to equal 8. And then my standard deviation is now 2.107. So now in the next part says, which measures of central tendency does the outlier affect? So we want the measures of central tendency. So the measures of central tendency are your M's, your mean, median, and mode. So which ones changed? Well, our mean changed, but our median and mode did not. So our mean increased, but the mode did not. The mode and median did not. Median and mode did not. Could they change? The answer is yes, they could change. So the mean increased. It changed the most. But the median and the mode did not change. The median could change because we're adding in an extra data value. So it could change, but it's not going to change a lot. It's not tremendously affected. Now, why did this happen? Well, the reason why this happened is because we use all values to calculate the mean. But we only, for mode, we don't. We only use the most common. So the mean, or median, is the middle, and it's just most common. And an outlier is not common at all. Now the median could change, but not tremendously, and that's because it uses some of the values. The next one says, what effect does the outlier have on the range and the standard deviation? Well, it affects both. So the range and standard deviation are both affected. And that's because the outlier is used in both calculations. And it forces the spread to increase. Now the spread will increase regardless if the outlier is big or small, because it forces these range, the minimum or the maximum value will be much further away from one another. And so will this outlier be away from the mean, because remember that standard deviation represents the typical distance that a number is away from the mean. I recognize that this was a longer lesson, but hopefully this was a relatively easier lesson for you. If you struggled with the calculator stuff, then that is fine. We'll certainly go through it next time I see you. Otherwise, I hope you have a wonderful day, and I will see you next time.